able to see what's going on that screen. But yeah, that black highlight value is 14958. So now I know the ID of Bemidji. I also know its call sign, which is BJI. That's useful. The name is capital Bemidji, all caps Bemidji. Again, short text. And I don't know if this is Access, just trying to help me as much as possible, but what I remember from programming class is capitalized Bemidji is not the same set of characters as all caps Bemidji, and yet Access is going to let me let this work too, as I recall. Let me just test that out. I don't know about you guys, that just disappoints me. Capitalized Bemidji string is not the same as all caps Bemidji, but okay, whatever. It did find it for me. It made my life a little bit easier. I suppose I should stop complaining. All right, where was I, Mr. Kapiski? What was I talking about here? I did find the value that I wanted. I wanted the station Bemidji, the station ID for Bemidji. What's next? I mean, I'm looking at all of the W bands here in this column, and I'm not seeing any 14958s. I guess I could probably, if all I cared about was the wind speed in Bemidji, I suppose I could say something like select star from WinDat, where W band is equal to 14958. Does that make sense? Sam is nodding his head. I will take that as, where did my exclamation point go?
I think WN.
Freaking, what?
I think WN is a short text.
It is. That's why I'm getting a data type mismatch here in my criteria expression. I tried to give a integer value to something that is a text value. So Access isn't going to help me that much. But hopefully, having seen that error message pop up, when it pops up for you, you'll realize, oh, it doesn't want an integer value, it wants a string value. Or maybe it's the opposite. Okay, so now what did I get as a result of my test query? I think I got all of Bemidji's wind values, right? I don't know if I can trust these 0, 0 values. Was the wind really not blowing at those times, or is that just a null value? The sensor isn't working. I'm not sure, but let's assume that zeros are fine. They are actually zero wind in the north, south, and east-west directions simultaneously. I do trust these non-zero values quite a bit better. One thing that I do notice is, since I did upload this data from a text file where the data was in some sort of order, probably date order, now that I'm retrieving all of the Bemidji rows, they are coming out in date order. So I'm looking at all these dates, and we can see that Bemidji is collecting data, every 20 minutes exactly. And I suspect that those are just average wind speeds. I bet that Bemidji is actually collecting data every 5 minutes or every 1 minute or something like that, and then over a 20-minute period, just averaging the last 20 values and storing that average. But I have nothing but experience to base that on. I'm not sure if that's exactly true, but I suspect that this value is not exactly what was happening at 6:55 a.m. on this date. I feel like they probably averaged it in some manner. But okay, so I know how to extract only Bemidji data from my wind data. All I need to know is Bemidji's W band to do that. And that's something that you're going to need to know for the next assignment. Know how to do. But before I completely lose track of what I started out doing here. I wanted to illustrate how to do a join in Access. And so, since we learned about comma joins, I'm going to tell you right off the top, Access does not understand what the heck you're talking about when you type natural join. And frankly, I'm fine with that because I hate natural join, but Access does not does not indulge you with that. It will allow you to type Bemidji in whatever case you want, but it's not going to let you give it a integer W-ban, and it is not going to allow you to make a join with natural join. And so I guess we're stuck with comma joins, and I don't think that I want to limit myself to Bemidji, so I'm going to need somebody to memorize 14958 for me for when I come back to that, and I will have inevitably forgotten the value. But for now, I'm going to delete that. And how do comma joins work, Aiden?
Takes Cartesian product of the two. So if
It-
you comma
yeah,
the
but-
station, you get the.
But what do I need to type? Comma is part of the name. I invented the name comma join, by the way. Real database people probably don't say comma join. From Windat, comma join station, right? Does case matter? I don't even know anymore. And in order for this not to be a Cartesian product, because, you know, comma joins work by going through Cartesian product, but we definitely do not want to see the result of the Cartesian product. We want to see the filtered result after the Cartesian product has had its way with our data. And so, how do I not see the Cartesian join, a Cartesian product result? Aiden, do you know?
I don't know how to do that.
A comma join. We're doing a comma join. You know how to write a join, a comma join in a relational algebra, don't you?
Sure.
It's actually the Cartesian product with a predicate, right?
So you just put that
Yeah.
conditional under it?
Yeah. What is the conditional that I need? What are you going to join these two tables on? It has to be a common field.
Yeah, so it's for the W then equals to like whatever you found.
Yeah. You know what? That's true. I should tell you what I'm looking for. I think I want to add to the end of each column in the win data table. I want to say the name of the station. I want it to say Bemidji for Bemidji's rows, or Las Cruces, New Mexico, or whatever for its rows or something. I want to grab information out of the station table and append it to the row in the data table, so I know where the heck this data is coming from. So I want all of the data from the win data table, plus the, what was it called, the name column from the station table.
I think it's
And I only want to join those rows together where the value of W-ban in the data table is the same as the W-ban row that I'm getting the name from in the station table. Right? So, how did the standard SQL that we've been using for the university database tests so far has been so everything from the win data table, win date dot, comma, station dot, name, I think is what it was. I'm just going to go back here and check. We have a name field. That's the name that I want to see. Maybe if you want the state as well, we could do that. Station.name and station.state. Maybe there are Bemidji's in other states, I don't know. Where I want these two things to be joined, and that joining predicate that we would normally put beneath the relational algebra X, the Cartesian product symbol, we're going to put that in the where clause in the SQL. And so that's going to be what? Windat.wban is equal to station.wban? Does that sound right? Luke, help me out here. I'm lost. I'm in the wilderness here. You know what I'm asking for, Mr. Kapinski?
I think so.
Tell me what to type. That's what I'm asking for.
Could you just do where, we're just looking for the Bemidji ones, right? Or?
No, not anymore. I just want to see that original data table and know where the data is coming from. So I want to see all the data and then have its sources.
Oh, okay.
And so I'm adding name and state to the end of each one of those rows here. And I just need to know how to join these two tables together.
So would it just be where windat dot wban is equal to station dot wban?
Misspelled WBAN. I think Access would let me, oh, why? I'm caps locked. Okay. Yeah, hopefully. Does that look right to everybody else? What is this going to give me, Mr. Late?
Is it going to give you every value in both tables? Or like the names and states of?
Yeah. I definitely think it's going to give me every value in the win data table, every row in the win data table, but that's what I want. And it is only going to give me the name and the state values out of the station tables, and it's only going to give me those two values for where the rows have the same WBAN number. And so that's what I want to happen here. I'm joining these two tables on the basis of common WBAN numbers so that I can see, instead of the WBAN number of the station where the wind data was collected from, I also want to know its name and its state location. So I guess viewing that result is another way of running the SQL, but I'll just run that to officially show. So what is this? What did I just get here? I'm not sure did I get what I wanted? Okay. ID is not, it is just, why do I have an ID here? That ID must be in the win data table. I must have allowed it to give unique IDs to each of the rows. I didn't want that to happen. So I have the impulse number from the win data table. The impulse number is basically saying which 20-minute section the data comes from, because I noticed that the fastest any station collects data, according to this data table, it is every 20 minutes. Some stations only collect it every hour. But so impulse number means on July 1st from midnight to midnight 20 a.m. It is somewhere within that 20-minute section is where this data value was collected. And by the way, this particular row, this particular data value was connected from the Panama City, Florida wind station. So the reason that you use joins is to make your data more understandable. I was looking at that wind data table, and I saw that I had a bunch of data, and I saw that it came from a bunch of IDs, but I didn't actually know where this stuff came from. And now I found a way to join together to this data the names of the places that collected this data. And actually, I mean, probably for homework too, I'm not going to ask you what the wind values were in Biloxi, Mississippi. So I'm probably going to ask you what the wind values were in Bemidji. And so, back to you, Mr. Kapinski. I have already forgotten what the ID for Bemidji was.
Was it 14958?
I believe it was. How am I going to modify my SQL query to return only these joined rows from these two joined tables for station 14958?
Add in and.
Yeah.
Just and when that WBAN equals 14958.
You're not gonna let me fool you again? Like that?
Yeah.
Yeah. All right. I do like making mistakes on purpose. There is no mistake yet in this guy here, but just to let you see what happens when these mistakes happen. What if I did this? What if I just said where W ban is equal to 14958? Is there anything wrong with that?
It's in both tables, so I wouldn't know.
Yeah, the error is going to say, I don't know which W band you mean, because there are two W band columns in the joined result, and so it wants to know which column to check. I'm just going to run this just to see what kind of error message it gives me. It says the specified field W band refers to more than one table listed in the from clause of your SQL statement. So yeah, Mr. Kapiski is apparently a database experienced in the ways of databases. He actually forced me to prepend that field name with its table name source. And in this case, I don't really, I don't think there's any difference between saying windat.wban or station.wban, because the whole point is they're only being joined because they're both the same. So we would get the same value either way, whichever one we used, but what the heck. Windat it is. That's what you told me, right? Okay. And there it is. I am getting data from all of the Bemidji locations. Also, the data is coming in ordered because that's the way it's stored on the machine. We can't necessarily count on that. So I'm just going to I think I've shown you this code before, but I'm just going to start introducing some SQL clauses to you without reading them to you first out of a PowerPoint, because I have realized with no class this Friday that I'm starting to run out of time. But I want to make sure that I get my data in ascending order. And so that clause, that's just a new SQL clause, the order by clause. I want to order by dat, I think it was, right? Or date? I wouldn't have named something date. It's dat. Okay. Order by dat. WinDat is the only table that has a dat field. And so I don't need to prepend it with anything, hopefully. And now I'm going to go back to query design and run that. And really, it's not going to change the order of anything, I don't think. Now we have everything in date order every 20 minutes or so. And also, the imp nose kind of reinforced the fact that I'm getting data from this one station, always Bemidji, Minnesota, for every 20 minutes here. I mean, sometimes the station does go out. In fact, during the time period I'm going to ask you to look at, the 2 days during which those storms blew through Bemidji, I think the Bemidji station actually stopped working for a while. Sometimes a twig gets stuck in the sensor and keeps it from taking measurements. Sometimes in the middle of winter on top of a mountain, the wind sensors will freeze and they won't unfreeze, they won't thaw out until the spring, and so a station just stops giving data for a while until somebody trudges all the way up to the top of that mountain and uses their gloved hand to clear the snow out of the little sensor slot, and then it starts collecting data again. Installing sensors out there in nature is not a simple business. There's always something that goes wrong. You think that you've planned for everything, and then a bird poops on your sensor and it stops working until you go out and clean it off. Oh. Especially installing sensors anywhere near the sea. Salt water is just going to eat your metal sensors up. So there is all manner of things. If you ever wonder why you're spending $100 for a tiny little sensor from digitkey.com, it's because of all the engineering they have to do to protect that sensor, to keep it safe from everything possible in the environment. All right, so I have demonstrated why you would want to do a join, and I did that with an inner join. I didn't do that with an inner join. I did that with a comma join. But if you ask ChatGPT, how do I type this SQL query in Access, it's not necessarily going to show you the comma join pattern. What Access actually likes to use is called inner join, and I think the book author talks about inner join somewhere towards the end of chapter 3. I'm just going to skip ahead to that. I actually prefer using the inner join version of joins. That is, instead of using a comma, I'm going to use the keywords inner join. And you're going to see that they're keywords because they're going to color up. And so I basically treat that inner join keyword exactly like the comma. But the reason I prefer inner join to the comma is because, actually I think this will work. Let me test this out. If I keep the predicate in the where clause with an inner join, will it still work? I suspect that it will. No, it doesn't. It doesn't like something about that. It thinks it saw the where clause unexpectedly early. It's actually expecting something else in your inner join section. And what it's expecting is inner join likes to have its predicate right next to it, which I don't like seeing the comma joined predicate in some completely different other clause. That's what offends my sensibilities there. But if I'm going to use inner join, I also need to use another keyword, on, I believe it is. And on says, and here comes the predicate for the inner join. That's what the meaning of on. I believe. I didn't test this out in my office. I better execute this query and see if it actually runs. Okay. Do you guys believe me that this inner join formulation delivered to me exactly the same data as the comma join formulation did? The only difference between the two, I did have you type a couple of extra keystrokes. You inner join instead of a comma. You had to put an on in there. But what I really like about this is it put the predicate right there next to the two tables being joined. And I just like that better. And I think you'll like that better when you later see the extent to which I overuse this inner join formulation to get my stuff done. But okay, here right now I have all of the Bemidji data that I care about together in one table, the result of this SQL query. And you know, I prefer this arrangement of data to the original arrangement of data that I got from the CSV file. I want to save this table as a physical table, not just as the result of an SQL query. I want to have not only a wind data table and a station data table, I already have another table. It's called TRF data. That's Thief River Falls wind data. How can I just put all of Bemidji's wind data into its own data table called BJI DAT, for example? Bemidji data. Anyone know? Has anybody been reading ahead in chapter 3?
I didn't
Yep, this semester?
project, but I found there was a make table query that just made an entire new table with the results of the query.
You mean in Access you use the make data query wizard? Yeah, the query wizard will come up with extra SQL formulations for you. And I'm just going to tell you right now, select all of this stuff. What do you want to select? All of this stuff. Where do you want it to go? Into a new table that I want to name Bemidji data. So I guess that's an into clause, but I consider that as a part of the select clause, really. That's just how I learned it. I think this will work. Does this formulation make sense to you? These are all the column names of data that you want. I want you to save them into basically create a new file for me named Bemidji data, a new table, and I want you to grab all of this data from the wind data table, join to the station data table. I only want the 14958 rows out of the wind data table. I want everything ordered by date, and I want you to save this data set as Bemidji data. Oh my God, I hope this works. I'm about to paste 999 rows into a new table. Should I click yes, Sam?
Sure, why not?
Okay. And so now I have a new table in my list here, Bemidji data. Double click that, open the thing up. I have all my date times here every 20 minutes. The ordering is the same because I just saved that result file as its own table. And I have Bemidji in Minnesota at the end of this thing. I guess I don't need that anymore. I kind of assumed that everything in here is from Bemidji, Minnesota, but what the heck. Now it's obvious. It's okay. I have a whole table of Bemidji data, Aiden. What do you suppose I can do with that? Do you remember from the assignment when that storm blew through town? Does anybody remember? Was it a July 4th storm, a July 2nd, July 3rd?
July 2nd and 4th.
Okay, that two storm fronts blew through, but the big one was July 2nd, right? So now that I have only Bemidji data, I can just look at July 2nd data and see where the wind values were the greatest. And actually, and that should give me some idea of when the storm occurred. So I'm looking at U's and V's here. So make these columns large enough so I can actually see these values. And yeah, I've got some pretty big values. Negative signs just mean south rather than north or whatever. So I have a 7 and a 7 here. So that's pretty big. That's the biggest that I can see so far. So it looks, oh, that was 6:55 a.m. I don't think that's when the storm blew through town. That would just happen to be a pretty big wind gust. Now I'm seeing 7s and 8s here at 11:35 a.m. I guess it was kind of a windy day. 7s and 8s counts as, okay, now I'm seeing 15s and 9s, 13s and 11s. You know, 20s and 3s. Which of these is the biggest wind gust, do you suppose?
The scientific notation one?
No, this is 8.3 times 10 to the negative 4th. That's a couple of centimeters right there. How can I determine the magnitude of wind if all these people give me, these pointy-headed nerds at the weather office, all they give me is a U coordinates and V coordinates? How do I get magnitude out of that? Do I have to be some kind of math nerd? Tyler?
You gotta turn to the dark side. Math. No.
How do I combine two values into one value? Do I just add them up? Plus sign. Come on, Tyler. Make things easy for me for once.
Euclidean distance
Oh, Jesus.
formula.
Okay. So what does that even mean, dude?
You gotta do the square root of one number squared plus the other number squared.
Okay, so this whole query was creating that data table. Now I have that data table. I should be able to type something vaguely simpler. Select U and V from Bemidji Dat. And so that's just going to give me those two rows. Let me just verify that I'm getting what I expect. Okay. I mean, maybe I want to see dates as well. I'll go back and add that in. So maybe date and U and V from Bemidji Dat. And I also want magnitude, and SQL will allow me to create a new field, a new column especially in an SQL query result by just typing in an expression. And so a nerd boy here is telling me magnitude is equal to what again? U squared plus v squared, and then what is the square root function in Microsoft Access?
SQR.
SQR is probably a pretty good guess. If it's not SQR, it's going to be SQRT or something like that. So I could ask a chat bot, but I'm just going to mess around and find out here. SQR of U, can I do U raised to the 2 power? Does that? V raised to the 2 power? Otherwise, I'm going to have to do V star star 2 or something, or U times U plus V times V. I'm going to get it to work somehow. And then I'm going to name this new column as the magnitude column. See if that works. Oh, it worked, guys. And so let me go down to that July 2nd data stretch where we were getting the big values, the 13s and the 10s and the 20s and the 3s. And it looks like the 20 and the 3 takes it. The magnitude of 20 units of power in one direction and 3 units of power in the 90, in the, it's not asymptotic direction. What is it, nerd boy? The 90-degree direction. You know what I'm asking for? I'm not sure what I'm asking for.
I think the -3 on the V means it's going slightly south, and then the U means, the -20 on U means it's going very far west.
I think so too. I think negatives mean west in the U column and negatives mean south in the V column. But yeah, so those are the components of the wind, and we're using the Euclidean formula. A squared plus B squared is equal to C squared, and we actually only care about C, and so that's why we took the square root of the sum of those 2 squares. And so that's telling us if we were drawing this magnitude on the board in the form of a vector on a map of Minnesota, it would probably be going mostly west and a little bit south. That is, it's going to be the sum of this westward vector plus this southward vector, and it's going to be about 20.99 units, whatever those units are. I assume it's either going to be meters per second, or since this is America, feet per second, miles per second, or something like that, and or maybe it's in knots. I don't know. Maybe we have to go to the weather station website to see in what units they collect their wind data to be absolutely sure. Because, I mean, didn't some bearded guy tell us that the wind was blowing at least 80 miles per hour or something like that? And I'm not seeing any 80s here, so either beardy guy was wrong or exaggerating, or I don't know what units these things are being measured in. What is a knot anyway? How can I convert from knots into miles per hour?
I found an online calculator for it. It wasn't
Yeah.
particularly close to. The only one that came close was meters per second.
Okay,
So
that actually makes some sense. And I do feel like I was looking at the metadata that I had downloaded from the website at the time, and they did tell me it was knots. And even then, this value doesn't make sense. But the reason that I explain it in my mind that it doesn't make sense, even if this is in units of knots, is that this is an average value. So yeah, it was probably blowing 80 miles per hour at some point, but they averaged different points together and didn't get the maximum value out of that. So that's another reason why I believe these are average values. I saved that metadata file somewhere, so I can put that up on the D2L if anyone cares. Does anyone care? You want me to put that up there, Veda? Come on, please say yes, please say yes, please say yes, please say yes. Oh, thank you. I don't know how useful it is, but at least you get the pointy-headed nerds version of what they were collecting and how, and in what units. But yeah, if you don't have access to that, that's why I asked you to answer that question as best you could. Do your own research, see how different NWS websites say they collect their wind data, and assume that these guys in Bemidji are doing the same thing that the National Weather Service does. You're probably not going to be far wrong. And if even then the data doesn't make sense, well, come up with an excuse like I did and said, well, this must be averaged data. I don't need to worry too much about that. Any other questions on that assignment that is due on Friday? Yes, Laura.
So on question 1,
Yeah.
you asked like what are the schemas of the WinDat and station?
Yeah.
Like, are you just asking for like what different information is in each table, or like?
Not really. Do you remember what I said about the single line schema when I was drawing it on the whiteboard on Monday? Drawing the schema as a single line. It's basically the name of the table, followed by parentheses, followed by a comma, enclosing a comma-separated list of all of the column names. The schema is just the design of the table. Or if I'm talking about database schema, the design of the database. But if I'm talking about the schema of a table, I'm saying, what are the column names in this table? What are the actual data type values that they're collecting, and what are their names? So that's all I was asking about. I just want a single line schema. Say the design of the wind data table is the ID field, and then the U field, the V field, or whatever the order of the data is. The columns are in that table. Any other questions? Otherwise, I think I'm at the end of my time. I hope I've impressed upon you the potential usefulness of joins, and I didn't get to demonstrate to you why I prefer using inner joins and having the as clause right next to that, but I'm probably going to get around to that next Monday when we next meet up here for database class. Until then, have a good weekend, everybody. Thank you very much for showing up. I will see you guys then.